In TIA Portal, there are different types of programming languages. There's ladder, which is a graphical language, and structured text or structured control language, which is a textual language. But predominantly, all of the different languages available aim to serve one purpose, which is to allow you to write your logic. Some languages have strengths and some have weaknesses, and when used together, you get the most out of TIA Portal. There's a lot of talk, especially if you're new to the TIA Portal or PLC programming environments, about sticking with one language. That is not the best way of getting the most out of TIA Portal. So, without diving in too much into an individual language, we're just going to take a quick look at a very basic example in each of the languages, just so you can get an appreciation of what the programming environment looks like for each language, and also what the strengths and weaknesses are, just in a nutshell, because we will have lessons later on that delve much deeper into each language. So I have an example here for a very basic bit of code in ladder logic, which is simply an input to an output. And this is the sort of environment that we would see. At the top here, we have the declaration window. Now there's nothing in here right now because this particular function block doesn't actually make use of any statics or items that belong to this object. I'm going straight out to these addresses here, which is an input address and an output address. And we just saw setting those up in our devices and configuration lessons. And down here, I have exactly the same logic, but written in structured text or SCL. And this one says the asset output equals the switch input. And there's also another way of writing it, which is if the switch input is true, then make the asset output equal true. And if the switch input is not true, so else, the asset output equals false. And again, this is exactly the same logic. It gets compiled to the same output or the same language that the controller would use, but it's presented in a completely different way. And the toolboxes and methods that you can use in different languages will differ from each other. In this one here, we have another graphical language, which is our function block diagram. And very similar to ladder, it's simply switch input in equals asset output. So whatever we pass in here equals the asset output. And again, exactly the same layout to the screen. We have the declaration window up here and the programming window in rungs and networks down here. CEM is cause effect matrix. This one does have some limitations, which we'll come into later on in the course. But for this particular example, we can do the same thing. However, you'll notice in the declaration window, this one does have some declarations. So cause one and effect one, that's this block here and this block here. They are owned by this function block, by function block 1.1.4 CEM. And these bits of information reside in this function block instance. Again, if you don't understand what I'm talking about at this point, there is a lot more information on this to come. So we don't need to worry about that right now. But up here is where some of this stuff gets declared and stored. Down here, just to walk through it, switch input is our cause. That gets assigned to cause one. And our effect is asset output. When switch input is on, the pathway here is to come through here and then up to our effect. So if switch input is on, our asset output is also on. This is quite a new language and not something that you would have seen if you've transitioned from older SIMATIC environments or some other PLCs like Rockwell. I do believe there's other PLCs out there that have a very similar style setup, but it is something that's nice to have, especially for very, very large cause and effect matrices that you want to put together that come from a lot of inputs and affect a lot of different outputs. It's quite a nice visual way of putting everything together. And then down here, we have a fifth language called Graph, which is sequential function diagram for those that are coming from CodeSys and other environments. Works slightly differently, but in principle is the same. So we have a entry point here, and we come down to S1, which is our initial step. I just click here. These are the instructions for this set, or this step rather, which doesn't have anything. There's no particular function that's happening on this step. All we're doing is waiting for this transition gate to allow us to move to the next step. If I click here, I can see that the transition gate is set to true when switch input is on. Notice that this is written in ladder. So we've got a bit of a hybrid language here between a graphical walkthrough of a sequence and then steps being written in this qualifier and action environment, which is similar to instruction list, and then the transitions being done in ladder. If switch input is on, we come down to step 2. And if I open step 2, we can see that this does have a qualifier action on it, which is N. N stands for just set whilst the step is active. Again, doesn't make much sense if you're brand new to this, but it will the more you use it. And here it's asset output. So if we are in this step here, asset output is set to true. And we got to this step by falling through this gate when switch input was on. We end up here, and we can only get out of this step when switch input is turned off. And then as we come down, you see this little arrow that says S1, which means return to step 1. And you can see it originates from T2, which is this transition here, ends up back here to repeat the process where we will wait in step 1 for switch input to open again. And that's quite a lot to take in for somebody who is completely brand new to this, but hopefully you can see that this environment is very, very different to the others, but you can still do the same logical output. And again, up here we have our block interface. This one has a lot more by default. All of these different inputs, which are things that need to be passed into the block from the outside world. And then we have all these outputs, which are statuses and other things that this block produces. And we have statics here, which are objects owned by the block. And you'll recognize that this transition 1 to step 1 and step 2 are items that you can see on the actual diagram. And then just to touch on the last language that we haven't been through, and I'm not going to go through it in this course because it's actually deprecated by IEC standards, although Siemens do support it in TIA Portal, is instruction list. And instruction list is a old school language by definition that allows you to do pretty much anything that you can do in ladder logic and function block diagram. People coming from Semantic Manager will be aware of instruction list, or should be aware of instruction list, because it was something that was commonly used, but it's not something that is defined as a standard moving forwards. And I believe Siemens only support it now in order to keep the sort of historic usage of it available and allow people to look after systems that already have instruction list in. So I'm not going to go through that. It's quite a big learning curve if you've never used it before, and especially if you're coming from graphical or more structured control languages in text. So that's basically an overview of TIA Portal's programming environment, what we see here. And then just notice in the project tree, we have different colored objects for our different function blocks, which are these blue ones. Pink ones for our OBs, our organization blocks. These are data blocks tied to instances. So we have our function here and an instance of our function here. And again, we will go through these in our blocks and structures section of the course, but as an overview, Hopefully that gives you some understanding of what we're about to dive into in more detail.